In this question, we expected to use f of x to find g of x. So the first thing that you need to do is to inspect and try to figure out the relationship between f of x and g of x. One way to do that is to look at this bit, right? That bit and that bit. And from there, you should be able to see a connection between these two functions. We can notice that g of x is equals to f of negative x. So basically, if you plug negative x in place of x in f, then you end up with g of x. So basically, you can go ahead and say, well, because we know the formula that represents f of x, we know the series that represents f of x, we can go ahead and just plug negative x in place of x in that summation to find a corresponding series that represents g of x. Okay, so what you're going to do is this. So this will be equal to the sum from n is equals to 0 to infinity of negative x to power n. All right, so what I've done is this. I'll repeat again to show you what I've done. All right, actually I need the yellow one, so that one. So basically what I've done is to plug in negative x in place of x in this series to find an equivalent series for g of x. All right, so we can go ahead and simplify this. So this will be equal to the sum from n is equals to 0 to infinity of, now we can split that to end up with this series that represents g of x. All right, and you can produce a few terms of this series. So we can say g of x will be equal to 1 minus x plus x squared minus x cubed, and so on and so forth. Okay, so that's part A done. Part B, we're required to use the result from A and the integration of power series to find the maclaurin series for h of x. Now, obviously, if you look at the relationship between g of x and h of x, we can notice that if you integrate g of x, then you end up with h of x, right? So you can notice that if you integrate, so part B, h of x is equal to the integral of g of x with respect to x. What I mean is this. If you integrate 1 over 1 plus x with respect to x, then you'll end up with ln x plus 1, of course, plus a constant. All right, but that's basically what I mean. If you integrate this guy, then you end up with that. So what you are going to do is this. Because we have a series that represents g of x, we can just go ahead and integrate that series to get a series that represents a maclaurin series that represents h of x. So we can go ahead and say the integral of g of x with respect to x will be equal to the integral of the sum from n is equals to 0 to infinity, all right, of negative 1 to power n, x to power n, and with respect to x. So basically what you're doing is, we know the series that represents g of x up there. So what I've done is just take that series and you're going to integrate it with respect to. Okay, so what we can do now is to move the integral sign inside the summation sign. So that will be equal to the sum from n is equals to 0 to infinity of the integral. Now actually before I plug in the integral, I'm going to take out negative 1 to power n as well. And then I'll have the integral of x to power n dx. Because you're integrating with respect to x, negative 1 to power n won't really be affected. So what we'll end up with here is the sum from n is equals to 0 to infinity of negative 1 to power n x to power n plus 1 over n plus 1. So that's just reverse power rule. Okay, integrate and you get your solution, and that is your final answer. In this question, we are required to use maclaurin series focus x to find the series expansion for this. Now, we are using maclaurin series focus x. One thing that I want you to look at is the connection between these guys. All right. So basically, the plan is this: we'll find the maclaurin series focus x from our formula booklet. Okay. Here it is. So we are going to use that series. Okay. And then write it down. And once we have written it down, we'll plug in 2x cubed in place of x, and we'll end up with what we want. So what I mean is this. We know that cos x, so maclaurin series expansion for cos x will be 1 minus x squared over 2 factorial plus x to power 4 over 4 factorial minus x to power 6 over 6 factorial, and so on and so forth. So basically we have that series goes up to infinity. Now what we want to do is to plug 2x cubed in place of x. So what I'll end up with is 1 minus 2x cubed squared over 2 factorial plus 2x cubed to power 4 over 4 factorial minus 2x cubed to power 6 over 6 factorial. Okay, and so on. So what we'll end up with here is we have to simplify this expression. So what we'll end up with is 1 minus 4x to power 6 over 2 plus 16 x to power 12 over 24 minus 64 x to power 18 over 6 factorial will be 720, and so on. We can simplify that further to end up with 1 minus 2x to power 6 plus 2 over 3 x to power 12 minus 4 over 45 x to power 18, and so on. And that will be our maclaurin's series expansion for cos 2x cubed.